Alright guys, and today we're going to continue talking about volume, and we're going to talk about pyramids and cones. So we're going to look at the formula for a pyramid, the formula for a cone, and then we're going to apply those formulas. So let's look at pyramids and cones, right? The differences between a pyramid and a cone is a pyramid is going to have some polygon for a shape, whereas a cone should have a circle. And they're both going to be going up towards a vertex. Let's take a look at a regular prism. Here we have a triangular prism. It's in a triangle. Let's say we were to divide this triangle into three different sections, right? So here's one section. Notice that it starts at the base, but then it goes all the way to this vertex. We have another one here, and another one there. So if you notice that we have three pyramids that make up this one, see? Three pyramids make up this one prism. So let's look at it from this side so you can kind of see it better. Here's the one pyramid of that prism. Here's the other one that slides into place. And then there's the last one that slides into place. Okay, so a prism is made up of three pyramids. So because of that, we can take the volume of a prism, which is volume equals big B times H, and just take a third of it if we want to take the volume of a pyramid. So that's what we have done. The volume of a pyramid is 1/3 the product of the height and the area of the base. That is our formula for a pyramid. A cone, since it is a circle, that just means the base is a little different. The base is going to be an area of a circle. So instead of saying big B, we say pi r squared, since that's the area of a circle. So let's take and look at an example of finding the volume of a cone, right? So volume is 1/3 base times height, but since we have a cone, we have a circle, we need the area of a circle, which is pi r squared. So when we plug in our numbers, we get 1/3 pi, our radius was 4, so 4 squared, and our height was 7. We multiply that out. If you're not pushing pi into your calculator, you should have gotten 112 over 3 pi. But if you go ahead and multiply that by pi in your calculator, you should get approximately 117.3 units cubed. All right, let's talk about the volume of a pyramid. So again, volume is 1/3 base times height. The base of this pyramid is a square. And remember, a squared is the area of a square is s squared. So since the side is 20, that means that the base, the area, is 20 squared, which is 400. Okay, now we need to find the height. Well, the height is a little bit tricky because it actually doesn't give it to us. It gives us this side here, and then it tells us that this length going up the pyramid is 20. And so we need to figure out what this height is right here. So we have to use Pythagorean theorem. We also are going to say that this piece of the triangle is 10 because it's going straight to the center of the square, and we know that half of the square is 10. So we know that this part of the triangle is 10 here. So Pythagorean theorem says 10 squared plus h squared equals 20 squared. Okay, we go ahead and solve for h, and we get the square root of 300, which means that volume is 1/3 times big B, which is 400, times h, which is the square root of 300. So if we were to plug into our calculator 1/3 times 400 times square root of 300, we would get our answer. All right, so let's talk about a new vocab word. There's something called a frustum, and that's part of a solid, such as a cone or pyramid, that lies between the base of that cone or pyramid and a plane parallel to that base, and it intersects with the solid. So think of it like as a piece of bread, like you're looking at just a portion, so it's cutting it off. Here, again, look, we have a smaller. It's parallel to the base still, and it's almost cutting that cone off. Alrighty, that's all I have to show today. It's your turn. 11.4, you're going to do 2 through 6 evens, and it is due in class with your notes.